In this example, we want to use the intermediate value theorem to show that the following function has a 0 in the given interval. Approximate that 0 correct to 2 decimal places. The polynomial function that we're working with is f of x equals 6x to the 4th minus 2x squared plus 5x minus 1. And we want to approximate this 0 on the interval from 0 to 1. So I got here the definition from our book of the intermediate value theorem. It says, let f denote a continuous function. So the function we're working with is a polynomial function, and polynomial functions are continuous. It says if a is less than b, and if f of a and f of b are of opposite signs, then f has at least one 0 between a and b. So in order for us to show that the function has a 0 in this interval, we need to test the y values. F of a and f of b are y values, and we need to see that they have opposite signs. So we need to calculate f of 0, and f of 0 would be 6 times 0 to the 4th minus 2 times 0 squared plus 5 times 0 minus 1. So that works out to be -1. And we need to test f of 1. That's 6 times 1 to the 4th minus 2 times 1 squared plus 5 times 1 minus 1. That would be 6 minus 2 plus 5 minus 1. So 11 minus 3 is a positive 8. And we can see that the y value here is negative and the y value here is positive, so they do have opposite signs. And so using the intermediate value theorem, we've now determined that there will be a 0 between these two x values. So there is a 0 between 0 and 1. There is an x-intercept between 0 and 1. So then we want to approximate those zeros correct to 2 decimal place. Now I'm sure there are many ways you can go about approximating those zeros, but I want to continue to use the intermediate value theorem. And I'll bring my graphing calculator in. And with my graphing calculator, I'm going to type that function into the y equals menu. I've got 6x to the 4th minus 2x squared plus 5x minus 1. And I'm going to use the table feature in my calculator. So I need to set this table up so it works properly. And I've got in here table start. So I want my table to start at 0, and I'm choosing 0 because that's the interval we're working with. So we want to start at 0. And I am looking to figure out the first decimal place. So I'm going to make this change in table. So it's going to increment every 0.1. And then I also need to change this to auto instead of ask. So I'm going to go into the table now, and you can see that my x's start at 0 and then start increasing by 0.1. Now again, I want to use my intermediate value theorem. So let me get a screenshot of this table so that we can write on it. So using the intermediate value theorem, it says that if we have a change in the sign, if we have opposite signs, then we are guaranteed to have a 0 between them. So looking right here, I have a change in the y values, negative to positive, so that means I've now narrowed my window down. Originally, we used the intermediate value theorem, and we said that we had a 0 in between 0 and 1. And now we've narrowed that window down, and we now know that the 0 is in between 0.2 and 0.3. So now we know 1 decimal place. Let me bring my calculator back, and we're now going to see if we can get the second decimal place. So what I'm going to do is, now I'm starting at 0.2. I'm going to go back to my table set, and I want to start at 0.2, and I want to get even more detail, so I'm going to go to 2 decimal places. Let's take a look at the table. And let's get a screenshot of this. Okay, so I got that screenshot. And I'm using that intermediate value theorem again, looking for opposite signs. So you can see here that the sign changes from negative to positive, and we have now narrowed the window down even more. So we now know that that 0 is in between 0.21 and 0.22. Now I want to do this one more time, and the reason why I want to do it one more time is because of rounding issues. We want to have it accurate to 2 decimal places, but if we are rounding up or down, depends on what the next digit is. So we want to know if the next digit is 5 or above, or if it's below 5, so we can figure out that rounding. So let's bring our calculator back again. And I want to go into that table set, so I'm going to hit second window. And now I want my interval to start at 0.21. And I'm going to get even more granular, 0.001. So we can now figure out this third decimal place. And let's go into the table. And once again, we're looking for that change in signs. You see the negative to positive right here. Let's get a screenshot of that. So now we can see, based on the intermediate value theorem, a change in signs. And so we're narrowing down where our 0 is even more. So now we know it's in between 0.216 and 0.217. And based on that next digit, I'm now going to round up. So we're going to say that 0.22 is our 0. So because both of those digits were greater than 5, I'm rounding up to 0.22. Thank you for checking out my videos. Have a great day.